Hello, hello everybody. We will now start with the next chapter in chemistry, that is nitric acid. So this is the third part of the section of study of compounds in your chapter in your syllabus. So this is nitric acid, that is chapter number 7C from Viraf Dalal. Okay, so we start with nitric acid. Now, nitric acid were initially called as aqua fortis, or we can say strong water. Aqua fortis means strong water. So, because it is having a very high amount of strength, so it's a quite a strong acid. That's why it was also called as aqua fortis. So in the 8th century, that's very long time ago, alchemists called nitric acid aqua fortis, meaning strong water, as a result of its corrosive action on many metals. So the metals used to corrode very easily with this nitric acid, and so that was in the 8th century when alchemists named it as aqua fortis. In 1658, Glauber prepared nitric acid by distilling niter with constant sulfuric acid and named it nitric acid. So it was in 1658 that first time it was prepared from niter, that is KNO3, potassium nitrate is niter, and along with a constant sulfuric acid. And in 1784, Cavendish determined the composition of nitric acid. So till the time it was not known that nitric acid was HNO3. It was just known that it was a particular compound which was formed by combination of certain substances. So it was the combination, or you can say the composition of the nitric acid was confirmed, or it was given or determined by Cavendish in 1784. Occurrence-wise, nitric acid occurs in the free state and in combined state. In the free state, during lightning discharge, nitrogen in the air reacts with oxygen to form nitric oxide, which is further oxidized to nitrogen dioxide. See, we very well know that nitrogen and oxygen are the two very important ingredients, or we can say the composition of the air contains 70% of nitrogen and 21% of oxygen. So we very well know that oxygen and nitrogen both are freely available in the atmosphere. Now, if nitrogen and oxygen are going to be combined, or if we say that there is going to be a reaction taking place between nitrogen and oxygen, it is going to take place only at very high temperatures. So when it requires such a high temperature, so the only condition in a natural form will be lightning. So when lightning strikes, a high temperature is being given to the nitrogen and oxygen, that the air, and accordingly nitric oxide NO is going to be formed. This on further oxidation becomes nitrogen dioxide. And nitrogen dioxide, when it comes in presence of the when it comes in contact with the moisture present in the air, because normally lightning will be there when rainfall is there or is about to be there. That's why moisture will be definitely there in the atmosphere in a huge quantity. This causes the formation of nitric acid in free state, as occurrence of nitric acid in free state. The nitrogen dioxide dissolves in the atmosphere moisture in the presence of oxygen in form of the air, forming nitric acid in this free state. The nitric acid which falls on the earth along with the rainwater may further combine with mineral carbonates in the soil, forming soluble nitrate. So this nitric acid, when it falls on the earth's surface, it will combine with the minerals and accordingly form nitrates. So the nitrates of the substances, or nitrates of the certain metals, are going to be formed by the action of nitric acid, which has come in the form of acid rain from the atmosphere, and from the rainfall, acid rain, and it is going to get combined with the soil to give you certain nitrates. So that is why nitric acid, or will be also in the form of combined state in the form of nitrates. This conversion of free nitrogen into useful nitrogenous compound in the soil is termed as fixation of atmospheric nitrogen. See, fixation of atmospheric nitrogen is very important process for the plants, because plants require nitrogen to produce proteins. proteins का one of the most important ingredient is nitrogen, which it is able to get only if it is able to get nitrogen from the air, but they cannot take in directly the nitrogen from the air, and that is the reason it requires fixation of nitrogen into the soil. So that fixation of the nitrogen into the soil is called as fixation of atmospheric nitrogen over here. So this is nitrogenous compound formed in the soil. So we have these equations. N2 plus O2 is NO, and NO plus O2 is going to NO2. So it is this way that N2 plus O2 will give me 2NO, and which is in the form when it is lightning discharge takes place. So in the case when lightning is there, so in the presence of lightning, this is going to take place. And this NO, when it reacts with O2, is going to give me NO2. So the formation of NO2 is going to take place. So yeah, this is going to be balanced like this. So NO2 is going to be formed, and this NO2 is going to react with H2O to give you HNO3. So according to the formation of nitric acid is going to take place. So of course there will be certain presence of oxygen also. So it will be, actually speaking, it will be NO2 plus, so 4NO2 plus 2O2 plus H2O plus O2 which is present in the atmosphere will give you 4HNO3 as the outcome over here. So that is how it is going to be formed, and accordingly how it forms the nitrates of the thing will be HNO3. So this HNO3, when it is going to combine with CaCO3, that is calcium carbonate, which is present in the soil, it is going to give you CaNO3 twice. That is the nitrate of the calcium. Plus we know that it is reacting with acid. So carbonates when react with acid give me salt of nitrate plus water plus CO2. So that's what is a general principle, that soluble nitrates are going to be formed. In combined state, in the form of salt, mineral salts, it is going to be in chilled saltpeter, that is NaNO3, and Bengal saltpeter, which is KNO3, which is also called as niter. So niter is KNO3 and chilled saltpeter is NaNO3. Now we come to the formation of nitric acid in the laboratory. So laboratory process, it's a very simple process, because here you are just going to mix two compounds and accordingly you are going to get the resultant thing. You are not going to add anything, no heating, kuch bhi nahi ho raha hai. So that's the thing over here. So what we have is a glass retort. Okay, a glass retort is the one which is having such kind of a spout outside. So this is called as a glass retort. So glass retort is going to be there, which is going to be heated, of course, and yeah, heating is required. And then you are going to take over here the the reactants. So the reactants over here is niter, that is KNO3 plus the concentrated H2SO4 will be there. Now remember again why we are taking concentrated H2SO4, because it is non-volatile, because only non-volatile acid can produce a volatile acid. So that's the reason it is going to be this way. Accordingly we will be getting KHSO4, and of course here also the same way what we had in HCl. HCl mein kya tha? The temperature was less than 200 degrees. So here also the temperature is going to be less than 200 degrees Celsius. And yeah, you are going to get HNO3 as the resultant acid over here. So yes, you are going to take over here the two compounds over here will be KNO3 and concentrated H2SO4. You are going to take in this glass retort completely sealed, and you are going to place a flask over here. The flask will be in this particular manner placed over here, and what will happen is you are going to pour cold water. So this is cold water. So tap water is being poured on this, so that the gases which are going to come over here, the gases of HNO3 are going to come over here, they are going to condense and give you over here HNO3. So the HNO3 which will be formed over here is because of the condensation of the gases, which is going to be the vapor state. This is going to be in vapor state over here. So these vapors are going to be condensed, and what we get is the HNO3. So again the same principle here. If I use the temperature greater than, so if I am having the temperature to be as greater than 200 degrees Celsius, then it is going to give me K2SO4 plus HNO3, whereas this is going to be a problem. So this again is a problem. So this is the problem over here because it is going to give the hard crust and things like that. So we'll come to the same thing again as we go through this thing. So what's the procedure? The procedure will be this way. You are taking KNO3, that is niter, and concentrated sulfuric acid in this glass red rod. Now glass red rod is taken and you are not taking. The most important thing is that in the whole thing over here, you are not having any rubber parts. Okay, it is completely glass apparatus. Even the top over here, the cap over here is glass. Everything is glass. Why is everything glass? Because nitric acid का जो fumes है, they are highly corrosive. So they would corrode the rubber which is used anywhere over there, and accordingly it is going to damage and leakage वगैरह होने का full chances हो सकता है. So that's the reason you will always have them to be as glass apparatus. The complete glass apparatus are going to be used in the laboratory preparation of nitric acid. So first thing is, yeah, KNO3 plus H2SO4 concentrate at the temperature less than 200 degrees Celsius will be KHSO4 plus HNO3, and the other option could be sodium nitrate. So you can use over here, instead of this, if the next could be NaNO3, and this will give you NaHSO4. So the same thing, there is hardly any difference in the two. Potassium and sodium can be replaced anytime, anywhere. So potassium nitrate and sodium nitrate, sodium nitrate can be taken with concentrated sulfuric acid. Product will be potassium bisulfate or sodium bisulfate, and nitric acid vapors will be formed. Condition will be the reaction is going to take place at less than 200 degrees Celsius. Procedure: a mixture of equal parts of weight by sodium nitrate or potassium nitrate and concentrated sulfuric acid are heated gently in the glass red rod. Observation: on heating the mixture in glass red rod, the volatile nitric acid is displaced and the vapors are collected in the receiver, which is cooled from outside with cold water. So we are just cooling it. We are not having any kind of downward displacement, upward displacement of air, downward displacement of water. कुछ भी नहीं है. It is directly we are getting the vapors. These vapors we are condensing and we are getting nitric acid. So collection: concentrated nitric acid vapors condense and are collected in water cooled receiver. So a water cooled receiver will be there, which is going to help you to get this thing. Precautions: complete apparatus is made up of glass. Since HNO3 vapors are corrosive, concentrated HCl is not used in place of H2SO4 as reactant because the reaction temperature is properly maintained and controlled. So what are the precautions we are taking? The first thing is that we are using everything of glass. Secondly, we cannot use HCl instead of concentrated sulfuric acid because it being a volatile acid. And nextly is the reaction temperature is properly maintained, because if you increase the temperature, you are going to get this thing which is hard crust. Identification: the vapors obtained in the receiver on heating alone or with copper turnings evolve reddish brown fumes of nitrogen dioxide, which turns acidified ferrous sulfate solution brown, proving the vapors are of nitric acid. So this is a test over here that first of all, whenever you are going to have this particular thing, if you are going to have certain amount of copper turnings added to this thing, the copper turnings, if you are bringing along, the vapors along with in the receiver obtained on the receiver on heating alone or with copper turnings will evolve reddish brown. So here the main thing is that nitric acid which is going to be formed is we can say slightly unstable compound, and due to the unstable compound being formed, the nitric acid continuously gives out vapors of NO2, and this vapors of NO2 will be much more if copper turnings are brought near it. So that's why if you heat this particular thing, you are going to get reddish brown fumes. So the reddish brown fumes of nitrogen dioxide, when it is seen, it proves that this is nitric acid. Secondly, if reddish brown fumes are going to be there in much more denser form when you are using copper turnings along with this thing. And also it is going to be, which is nothing but the formation of nitrogen dioxide gas. and which also what you can see is the nitrogen dioxide which is going to be formed, which is going to turn acidified ferrous sulfate solution brown, proving that the vapors are of nitric acid. So these are some tests. We will be going through the test once again in the later part of the chapter. Right now we will first of all go for the reactants, apparatus and the details about the same. So first is sodium or potassium nitrate is distilled with concentrated sulfuric acid. Concentrated sulfuric acid is used since it is strong, non-volatile acid and capable of displacing the more volatile as nitric acid from the later salt, that is KNO3 and NaNO3 on heating the reaction mixture. So yes, they have got the capacity. The concentrated sulfuric acid has got the capacity because it is strong and non-volatile acid, so it can easily displace or it can easily give out the more volatile acid from the salts of nitrates or nitrate salts. Concentrated sulfuric acid, hydrochloric acid is not used in place of sulfuric acid since being volatile, it is not used to displace another volatile acid. So because it is volatile, it itself will fume out, and that's why it is not used in case with another instead of H2SO4. The molar ratio of the reactants in nitrate to acid is the ratio 1:1, since even though sulfuric acid is dibasic or acidic salts, HNO3 is required to form, only half of the hydrogen of the acid is going to be used up. So you can see over here in the reaction itself, but even if this is dibasic, it is dibasic, so actually speaking it could have easily given me 2 HNO3, but here it is going to only one. Why? Because one of the H is going to retain over there in this particular form as bisulfate. The formation is a formation of bisulfate and not into a sulfate. That's the reason you are going to use only in the ratio 1:1, even if you have got 2 hydrogen atoms available in sulfuric acid. So we will be using it 1:1 because only one part of NO3 and one part of H are going to combine together to give you the resultant HNO3. All glass apparatus is used in the above laboratory preparation. The apparatus consists of a glass retort in which the reactants are heated and a water-cooled receiver to collect the condensed vapors of nitric acid. So yes, this is the glass retort, and this is the glass flask which is going to be used to take the condensed nitric acid. The complete apparatus is made up of glass only, since the vapors of nitric acid are being highly corrosive, attack rubber, cork, etc. See, nitric acid vapors are highly corrosive, and because they are highly corrosive, they are going to be corroding the cork or rubber kind of stoppers if we are using in this apparatus. Hence we are seeing that even the stoppers are made up of glass and not of rubber or cork. Temperature of the reaction, as I told you, it is around 200 degrees Celsius, less than 200 degrees Celsius, so that you are getting KHSO4. You are not taking more than 200 degrees Celsius, because the moment you take it more than 200 degrees Celsius, the problem will be there will be K2SO4 formed. So around about 200 degrees Celsius, it will be NaNO3 plus NaHSO4 will give you Na2SO4 then HNO3. So this is damages the glass apparatus. First thing is, of course, we know that if the temperature is more than 200 degrees Celsius, there are chances that could damage the glass apparatus. Second, further deposition of the nitric acid, decomposition of the nitric acid, because we know that it is already unstable compound. So if you are going to heat it at a much too higher temperature, it will form into, means it decomposes into NO2. So that's the reason you are not going to heat it much more. Third thing is formation of the hard residual crust of Na2SO4. So the hard crust of the corresponding sulfate Na2SO4 or K2SO4 being a poor conductor of heat sticks to the glass and cannot be easily removed from the apparatus. So accordingly we see that we will try to maintain the temperature to be less than 200 degrees Celsius. Also in the earlier part in HCl we also learned that there is a possibility that there is also the thing that it will waste the fuel, because when you are having the temperature more than 200 degrees Celsius, you will be wasting the fuel also. So that is how we see about the preparation of nitric acid. Now nitric acid, as I told you, is the acidic vapors which are there are unstable. So the pure the color of the pure nitric acid differs from the color of the nitric acid obtained in the laboratory. See, pure and the one which is obtained in the laboratory will be slightly different. Pure nitric acid is colorless. It doesn't have any color at it. It is completely clear. But the one which is available to us in the laboratory will be slightly yellowish in color because of the decomposition of the nitric acid to nitrogen dioxide. So reddish brown fumes are going to be coming out, which will make the whole solution convert into reddish, or it's not reddish, yellowish will be there. While the nitric acid obtained in the laboratory is slightly yellowish brown due to the decomposition of acid, which is negligible at ordinary temperature but substantial at high temperatures. Decomposition of nitric acid results in the formation of reddish brown nitrogen dioxide, which remains dissolved in the acid, thereby imparting the color to it. So that's why we have over here that 4HNO3 is going to give me over here the reaction as 4NO2 plus H2O plus O2. So this is the decomposition reaction. So 2 and 2H2O. So this is the decomposition reaction which is going to take place of the nitric acid. Accordingly, you see that you are going to get this particular fumes which are reddish brown in color. So this reddish brown color fumes which are going to be given out on heating of the nitric acid or hot nitric acid is going to make the nitric acid look yellowish in color in the laboratory. So pure, that's why we say that the pure acid will be colorless, but the nitric acid obtained in the laboratory will be yellowish in color. So hence concentrated nitric acid appears yellow when it is left standing in a glass bottle. So this is the important part, that why it is yellowish in color. Now this yellowish color which is seen in the glass bottle can easily be removed too. It is not that it is a permanent thing, it can easily be removed too. So it is, first thing is that what you can first do is bubble inside, bubbling of air or carbon dioxide. So which drives out the reddish brown nitrogen dioxide from the warm acid and further oxidizes nitrogen dioxide to nitric acid. So what we are going to do is add certain amount of carbon dioxide or certain amount of air or bubbling air into that particular glass bottle. If you are bubbling some air into it, the nitrogen dioxide will be driven out, or and plus it is going to get oxidized to form nitric acid. And another thing is dilution with water, because dilution of the nitrogen dioxide which is soluble in water. So nitrogen dioxide is soluble in water. So if I add some water to it, it is going to get converted into nitric acid. So these are the two ways by which we can remove the yellow color of the nitric acid which is present in the laboratory. So first one was we are adding some amount of we can add some amount of water so that nitrogen dioxide gets mixed up with water and form nitric acid, or else we can pass some amount of air or carbon dioxide into it so that nitrogen dioxide gets oxidized and form into nitric acid. So this is how we are going to remove the yellow tinge from the nitric acid. So that was about the preparation of the nitric acid in laboratory and the equations based on this. So this is it. So this was the main part about this particular part. Now we move on to the next part, and that is the preparation instead of laboratory preparation. Now it is the large scale production of the nitric acid. That means industrial production or industrial process or manufacturing. Now the industrial process is called as Oswald's process. Okay, Oswald's process. Now, as such, this particular Oswald's process is cancelled from your syllabus. So you do not have the Oswald's process in the syllabus. So you need not learn it completely. But there are certain parts of it which needs to be done, and that are the types of the reaction which are going to take place over there, and the conditions and the temperature part. So the only part which is required is the one. So we can just quickly go through the process. So in that process, what we are having is you are going to have four basic parts. So you have got four parts, that is A, then there is B over here, then there is C over here, and then there is a D over here. So these are the four parts. Now first part is called as a catalytic chamber. catalytic chamber. The second part is a heat exchanger. The third part is oxidation chamber. And then the final one is absorption tower. Okay, so what we are having is two compounds, two raw material. One is dry NH3 and another one is dry air. So dry NH3 and dry air, because we are requiring oxygen, O2, which is being required over here. So NH3 and O2 are going to be coming over here, and then this is going to be passed through, so that the nitrogen from here and oxygen from here is going to give you NO, and this is NO going to be coming over here, out as here, and steam will be there, and then finally it is plus oxygen will be there. This on heat exchanging over there, it is going to go into the cooling coils, and then it goes to the oxidation chamber. In the oxidation chamber, it is going to become into NO2 and O2, and finally it is going to be combining with the water to give you the resultant, which is HNO3. So these are the things. So if you see the reaction, it is this way. In the A part, the reaction is NH3 plus 4NH3 plus 5O2 under the presence of which the catalyst is there. So this platinum is the catalyst, and the temperature over here is 800 degrees Celsius. It is going to give you 4NO plus 6H2O. Now, if you remember, this is what we studied in ammonia. Ammonia chapter, we had got catalytic oxidation of ammonia. I told you there are two ways of the ammonia is going to be heated. One was directly heated in the air, and it gave us the yellowish, greenish yellow flame. And the second one with the platinum. So in that glass chamber, we had the platinum wire, and the ammonia was passed through it with oxygen, and you got this particular same reaction at 800 degrees Celsius. You got NO plus H2O, this NO was mixed with O2 to give you NO2. So the same process where NO is getting converted to NO2 is the thing what we are doing in case of production of nitric acid. So we have the first case in this way, and the second part is just the heat exchanger. So we are just heating this process. So B, there is no reaction over here, but in the case of C, that is the oxidation chamber, this NO2 is going to, so 2NO plus O2 is going to give me 2NO2. So the formation of NO2 is going to be taken, and that will be at a low temperature, that will be only 50 degrees Celsius temperature, and then this NO2 is going to be further in the D part, that is absorption tower. This is going to be 4NO2 plus 2H2O plus O2 is going to give me as 4NHNO3. So this is how we are going to get the nitric acid in the Oswald process. So what are the different things, or what are the important thing we need to learn is firstly the equation. So this equation is the most important part. So this equation is important part of Oswald process, that is the catalytic oxidation of ammonia. Catalytic oxidation of ammonia is NH3 plus O2 is going to give me NO plus H2O. Now this takes place in the catalytic chamber over here, after which it is going to pass into with the help of heat and steam. So it is going to get heated up, and on heating up, it is going to give you finally NO plus H2O over here. This NO plus H2O is going to be cooled, and then it is going to made through the oxidation chamber. After the oxidation chamber, it is going to become NO with O2 is going to give you NO2. So on this NO2 what will be getting over here is going to be going into the absorption tower when it mixes with the water and the oxygen to give us the nitric acid as the end product, which is taken out. So that is the industrial method process. So we have over here catalytic chamber, then we have got the oxidation chamber and the absorption tower, and yeah, what important thing which if you are missing out, I'm just checking out. Higher ratio of air is used. The air to be used over here will be at higher ratio because we are taking only the oxygen part over here. So air is used in all the three main reactions. The manufacture of nitric acid, that is the reactant in the catalytic, oxidation and absorption tower, including oxidation nitric oxide to nitrogen dioxide, which requires excess air. So only about 21%, that is 1/5 of the volume of air, is oxygen. That is why we need to take more amount of air over here, because it is used over here also, and here also. That's the reason we are going to use more amount of air in this particular place. And also the reaction in the catalytic chamber, the here initially it is taken at 800 degrees Celsius, but afterwards this reaction is a exothermic reaction. Being exothermic reaction, the heat is already going to be generated on a regular basis, and that's why later on we don't need to heat this particular thing. So since the reaction exothermic nature, the electrically heating is done initially only. The heat evolved that in the reaction further maintains the required temperature, which is going to be rare. Lastly is the oxidation chamber, wherein the NO plus O2 is going to give you NO2. Low temperature is used since they facilitate easy oxidation of nitric oxide and nitrogen dioxide. So for ease oxidation, you are getting lower temperature, that's only 50 degrees Celsius. And also minimize the decomposition of NO2, because the vapors will be formed, you don't want it to decompose, that's why you're going to keep it at a lesser temperature. And finally is the absorption, wherein you are a steel tower where quartz stones are there from which water is sprinkling down, and then NO2 is going to be reacting with O2, H2O plus O2 to give you HNO3. Quartz is used since it is acid resistant, so otherwise we could have not used quartz. The quartz is packed in layers. It slows down the movement of the gaseous NO2 entering from below and initiates better solvation of nitrogen dioxide in water. So that's about the quartz part. And finally, dilute nitric acid, which is collected at base of the absorption tower, can be further concentrated so it is up to 50% concentration, and then it can be concentrated by distillation up to a temperature of 121 degrees Celsius, because after that it forms a constant boiling mixture. So only up to 51, and then you, at 121 degrees Celsius you can get up to 68% concentration. Further distilling with constant sulfuric acid under pressure, reduced pressure, results in the fuming of nitric acid at 98% profit. So that is why 98%, if you want 98% nitric acid, you will have to do distillation with concentrated sulfuric acid. So anyway, as I told you, this part is not there. What you need to remember is this equations. Otherwise you don't need to require to learn anything about the osmosis process except for these equations over here and the temperature connected to it. So that was about the manufacturing process. We'll continue further in the next video.